So today, a new GPT-4 Turbo model, a majorly improved version, was released in the API. This is a truly multimodal model, I believe, with vision capabilities. You can now use JSON mode with vision and with function calling, but we are actually interested in its reasoning capabilities, and we are going to test it along with all the other models from OpenAI 3.5 and 4, and also Claude 3 Opus, Sonnet, and Haiku on two different problematic reasoning issues. So we'll be testing it on two reasoning problems. I can't remember where I found these problems from, but I believe it was from your Code Your Own AI YouTube channel. I wish I can remember. So these problems are as follows. So we have these two problems, and usually speaking, when it is asked in this good form, then GPT-4 was getting it mostly right. But when you move a sentence around, for example, the ring also has yellow cards. When we move the sentence to a different position, then actually the performance dips. The answer is supposed to be 23 yellow cards. And the same is true for the second example, which the answer is 24%. You can pause the video and actually read the problems yourself. But what we're going to do is actually we are going to take both of these problems. We are going to reorder the sentences in a combinatoric way using permutations, and we're going to shuffle them. And we are going to pick 20 random examples from those sampling. And we're going to run it with all these models, GPT 3.5 all the way from 0125 to 16K. And we're going to also use the new model, GPT-4 Turbo, plus the 0125, 1106, and the 0613, just to see how they do. And we're going to do the same for Claude 3 Opus, Sonnet, and Haiku. To do this in parallel, we're going to be using thread pool executor. If you want to see each run sequentially, you can set the parallel run amounts to false. If you set the stream to true, and you'll actually be able to see the streaming responses from the API. Let's try it with the first model. So this is going to run in sequence. If we were to start this, we will see, and I will talk about the code while we're doing this. By the way, the code files for this will be available at my Patreon. The link will be in the description. We initialized GPT, and here is its thinking process. And here is the answer. It is at 23, and we marked it as correct. And here is the second one. That is correct. And here is the third one. That is correct. So I canceled that run because we want to do this actually in parallel, but you can actually, this is how you can run it in sequence and see the results yourself. What we want to do is actually set the parallel runs to 20 and set stream to false. And we are going to test 20 combinations out of the mixed sentence structure of either one of these problems. So we're going to pick 20 randomly sampled combinations of sentence variations from problem 1, and then later problem 2, and we're going to test it on all these models. So let's actually go ahead and do this. Let's first start with the GPT. I'm just going to go ahead and click play so we can observe what's happening. We're going to be reviewing the code too, but like I said, the code files will be available at my Patreon. The benefit of this script is that you can actually pick different problems along with different system messages, so you can test different models and different problems with the script, and in parallel using thread pool executor. As you can see, we are going through the 3.5 models pretty quickly. The results for the 0125 came in. Actually, it was able to answer 17 out of the 3 correct for the bumper car problem. The next one, 1106, actually got only 14 correct and 6 incorrect. We'll actually review these. We can actually go ahead and clicking here, start a split terminal. So we can actually run the Claude test in parallel to, just going to say Python, and run the Claude version as well. And let me pull this up. So we are testing the problem. We first print the problem, and we print which model we're testing. We do the same here as well. See. So we see which model we are currently testing. And we have hit our rate limit, but we are actually going to retry. We have a retry mechanism in place. And we will actually continue. And as we get the results, we are going to be saving to here. We have actually made great progress, and we got the Opus's result too. So let's go ahead and see the results for GPT 3.5 Turbo. This is the latest model, which got 17 correct and 3 wrong. This is the next model in timeline, correct 14, incorrect 6. This is for the bumper car problem. And then the next one up is, I believe, this one, 0613, which got 15 correct and 5 wrong. And we have this Turbo 16K, which only got 14 right and 6 incorrect out of the 20. And our first problem was bumper. Let's take a look at GPT-4 Turbo, the latest model bumper car problem. It's got all of it correct, 20 correct and 0 wrong. The bumper car problem for GPT-4 0125 is actually, again, 20 correct and 0 mistaken. And for GPT-4 0613, it is actually 20 correct and 0 wrong as well. So this problem, actually 106 preview also got all of it correctly. So the bumper car problem apparently is not a big deal for GPT-4. We can also take a look at Opus for bumper cars. We got 19 correct and 1 wrong. Sonnet for bumper car got 17 correct and 3 wrong. Haiku for the bumper car problem got 18 correct and 2 wrong. Now continuing to the Marcus problem, which is a logic math problem. So the latest version of GPT 3.5, this one for the Marcus problem, only got 1 correct and 19 incorrect actually. So this is a much harder problem. Apparently, the next 3.5, 1106, actually got 2 correct and 18 wrong. 0613 version got 6 correct and 14 wrong. Sometimes people say that 0613 was a better model, perhaps. 3.5 Turbo 16K actually got only 2 correct and 18 wrong. The latest GPT-4 that was released today actually got 17 correct and 3 wrong on the Marcus problem. GPT-4 0125 got 17 correct and 3 wrong. And the 1106 in the Marcus problem got 17 correct, 3 wrong. 0613 for a Marcus problem got 15 correct and 5 wrong. So actually the latest model performed perfectly on the bumper car problem, and then when the Marcus problem got 17 correct. Let's see how Opus did. So in bumper problem, it got 19 right, so latest GPT actually beat it. All GPTs actually beat it, as a matter of fact. They all got this one correctly. And for the Marcus problem, Opus got 17 correct and 3 wrong. And the latest GPT-4 got 17 correct and 3 wrong as well. Sonnet for the Marcus problem got only 8 correct and 12 wrong. So we can compare maybe Sonnet to 3.5. And when we look at the latest 3.5, it actually, for the Marcus problem, is actually getting, 3.5 just couldn't do the Marcus problem at all. Let's take a look at Haiku. Haiku for the Marcus problem did 13 correct and 7 wrong. So Haiku actually beats 3.5 all the way and actually does almost as good as 0613 version of GPT-4. So there you have it. So these are the results. So we but here is our question. Was the latest model, 2014 that was released today, is better than the previous one? Let's take a look at it. In the bumper car problem, they both got it perfectly right. And in the Marcus problem, it was 17 correct and 3 wrong. And the latest one actually did exactly the same, 17 and 3. So at least in this test, we couldn't see a difference. So maybe if we were to run it for more combinations, we could see a difference. We can actually go ahead and do that. I'm going to go ahead and delete these results. And we're no longer going to run the Claude option, but we just want to run. So let's go ahead and comment this out. I want to run the latest model versus the previous 0125 preview. And let's do combinations to test to 50. And then let's see what kind of results we get. Let's go ahead and run this. And now we can review the code. Okay, we got our first result. GPT-4, the latest model that was released today, actually, again, got all the bumper car problems correctly, 50 out of 0, 50 versus 0. We are waiting for GPT-4 0125 preview to finish. Okay, for the bumper problem, it did 50 out of all 50 correct as well. But the real problem was the Marcus problem. Let's see how it does. Okay, we got the result for the latest GPT-4 for Marcus problem. It got 41 correct and 9 incorrect. And we're now waiting on the 0125 preview. Okay, we have the results for the Marcus problem. And it got the previous version of GPT-4 got 37 correct and 13 wrong versus 41 correct and 9 wrong. So just from this comparison alone, we can say that perhaps the latest GPT-4 did do better in this reasoning task. Now let's go ahead and review the code. The code is going to be the same, pretty much the same for the GPT and the Claude version. So I'm just going to review the GPT version. I am using the simplified Claude unified class I've created, plus a simplified OpenAI unified class. If you want to watch the full video on the OpenAI unified, you can find it at my website, echohive.live, along with all my other videos. It's this one right here, OpenAI Unified API. And if you're a patron, you can find the code download links here quickly too for each project. So let's take a look at this. We are going to define parallel run amount. Like I said, you can feel free to change this to depending on how many threads you want to start, but you don't want to start too many threads all at once. 20 is a good number. We're going to set stream to false and combinations to test to 20. Let's bring this whole model list back up. So you define your models, which we're going to loop over. This is our first problem statement. This is our second problem statement. We turn them into a list and we loop over those problems and we print which problem we are testing. This is the system message. Feel free to change it. We split the problem into its individual sentences by looking at the sentence endpoints. And then now that we have this list, we use the itertools permutation to create all sentence combinations. And then we print how many. For example, for the first problem, there's 120 combinations. And then we shuffle them. And then we have this function, which we are going to use to run the thread pool executor with, which is going to take in the sentence combinations and a model name. We're going to dynamically to use the model name from the list. And we use the GPT calls class, set the streaming to whatever we've set in the beginning of the script. And also we set our model to whichever model we're currently going to be using. And if we don't have a system message already, we add a system message. And now we get our reordered problem, turn it into a string from that sentence combination list, which is passed into this function. And now we add that message to the GPT's message history. And while true, we're going to try to get a response using the get response method of OpenAI Unified. If we get a response, then we're going to break out of it. If we get an error, we can print the error. But if rate limit error is in there, we're going to just print rate. We hit a rate limit error, and we're going to sleep for 30 seconds, and then we're going to continue. Once we get a response without errors, we're just going to break out of this. So if the problem is the first problem, then we are looking for a 23 in response, so this will return true. And if it's the other problem, then we're looking for 24% in response, so this will return true. So here we're going to loop over the model names for each problem, right? And then we're going to print which model we're testing. This, I guess, is not important. We can comment this out. Oh, I'm sorry. Actually, this is the dictionary we initialize. This is why I said you can test different system messages, because this dictionary will include the system message you have specified and how many correct and incorrect you've gotten per model, plus per system message. So you can actually test different system messages. Just remember that. With thread pool executor, we're going to initialize max workers based on parallel runs amounts, which we have specified in the beginning of our script. And then we're just going to call the check Claude response with the combination and the model name. And for combination, so this is a single line of code. We call this function for as many combinations as that in the sentence combination, but we're going to slice it up to combinations to test, which we have specified up here. Okay. And as those features get completed, we append it to this dictionary, and then at the end we count. If you run this multiple times, it'll actually keep track of the file numbering system, but it's going to save as results for model name for the first 10 digits of the problem. I guess this has to go to the end. You can modify it. That's just to enumerate the files if you keep running this multiple times, so it won't overwrite. So that's it. So that we write them to JSON, so we get a result like this. So this is pretty much it. I hope you enjoyed this. Let me know what you think. Thank you for watching until the end. For the next few minutes, I'd like to talk and explain about my auto streamer, the newest version 3. I will go ahead and start it. You can actually download a free demo of this app, and once you click on it, it'll take you to Google Drive. The app is launching right now. We'll give it a second. So if you're at the AutoStreamer's website, if you want to download it, you can click on the free download, and you can download it from the Google Drive. Otherwise, you can click on download full app, and it'll take you to my Patreon. And once if you do decide to buy it and download it, you will get something like this. And all you have to do is click on autostreamer.exe, and the standalone Windows app will launch. And all you have to do is put in your API key. It'll also auto-detect it from your environment variables. And then you click on generate course and just type in anything you would like to learn. For example, I can type in future of AI. You can also select code-based topics if you want to learn like coding. Let's actually go ahead and do that. And I can say Python dictionary methods. This can really be anything you like. You can here select how many chapters you want to create. Let's go ahead and select 2. Click on generate course outline. So this will go ahead and generate a course outline for us, which we'll be able to review here in a moment. Okay, curriculum created successfully. Now we can go to view course outline and find our dictionary. We can do a search and review the course outline. If we like what we see, we can actually go ahead and select this. There's also a search option. And then click on generate course. But before we do that, we have already selected it. As you can see right here, course is selected. We can actually see how detailed we want it to be. Let's set this to 100. You can select the web theme. You can generate and play with the audio will start playing right away. You have 6 different voice options and over 50 languages. You can also customize what appears on the web page. I'm just going to go ahead and click generate course, and it will launch a website and create this in real time. Because we selected generate and play, it will play the audio. Let's just give it a second.
A dictionary. In Python, a dictionary is an unordered collection of items, while other compound data types have only value as an element.
As you can see, there's the play pause button. I can pause the generation process. Maybe if I was recording this or live streaming, as I'm doing right now, recording a video, I can actually talk about this and then come back to it and click play again.
The dictionary has a key.
To continue. I can also stop this generation. I'm going to go ahead and do that. And we'll see, but if you generate your course to the fullest, then you will be able to view all your generated courses here, and you can actually launch them, like All Great Philosophers of the World, which is a course I created. And we can actually review this course and
Socratic Method and Plato's Republic.
Click and listen and read through them. Like I said, this header and the footer link and the text can be customized from these settings. Yeah, if you like what you see, if you want to learn more, please go to autostreamer.live. Link is in the description. There's a quick video there too, and an FAQ. And if you have any questions, you can contact me at Discord or Twitter. Just let me know. Thank you for watching, and I'll see you in the next video.